Look at this chart. Today's chip output estimated at 20. The TERAFAB target, 1,000. That's not a 10% improvement. That's not even doubling. Musk is claiming roughly 50 times current global AI chip production per year from one facility. And the even weirder part, most of it isn't meant to stay on Earth. So before we get into whether any of this is real, let's talk about what they're actually building and why the plan involves sending compute to space. Here's Musk's own tweet announcing it, produce over a terawatt of compute per year. And here's the line that stopped people cold, roughly 80% of that aimed at space, 20% for the ground. So immediately the question is, what on Earth or off it needs that much compute in orbit? This slide is the core pitch. On Earth, data centers are running into two hard walls: power, grid, strain, and heat. You can only cool so much silicon before you're fighting physics. But in orbit, you get continuous solar power, no grid, no permits, no blackouts. And for cooling, you just radiate heat directly into the cold of deep space. The argument is basically, as launch costs fall, those advantages start to look less like science fiction and more like a genuinely better infrastructure play. This table makes it concrete. Earth data centers, strained grids, water-intensive cooling, scarce land. Orbital data centers, 24/7 solar at 9 times the intensity you get on the ground, radiative cooling to deep space. The physics side of this is actually solid radiation cooling is real. But then, look at the operational column. Autonomous, robotic servicing, satellite mesh networking, that's where the execution risk lives. Launching it is one thing. Keeping it running in a radiation-soaked vacuum? That's a different problem entirely. And that's exactly where TERAFAB comes in. This Tesla post puts the demand case in one place: 100 to 200 gigawatts of chips just for Optimus robots, terawatts for space-based AI satellites, and the claim that this demand already exceeds global manufacturing capacity, even projected out to 2030. That's the justification for not buying chips from someone else. They're saying the supply simply won't exist. But before we get back to orbit, we have to come back down to Texas. Because TERAFAB starts as a brutally physical problem: land, power, supply chains, and a manufacturing operation that would make this gigafactory look like a pilot plant. The Austin Advanced Technology Fab is step one, and the key idea here is one roof. Design, masks, fabrication, packaging, testing, all in a single tight loop. Right now, chip development involves handing off between multiple companies across multiple countries. That adds weeks or months to every iteration. Musk's argument is that collapsing that loop into one facility turns iteration speed into a competitive weapon. If they're right, it's a superpower. If they're wrong, they've built the most expensive bottleneck in manufacturing history. This slide spells out the strategic logic. One factory serving Tesla, SpaceX, and xAI. Designed through tested silicon in a single pipeline. The core claim: AI demand is outpacing foundry supply, and vertical integration beats waiting in queue. Think about what that means. TSMC's lead times are already a strategic vulnerability for any company that depends on them. Musk is essentially saying, we can't afford to be a customer anymore. We need to be the factory. Here's the operational twist. Musk says TERAFAB will technically be 2 fabs, each making only one chip design. The goal is to strip out complexity, simplified process flow, faster FOUP movement, and a research fab that can iterate on a new chip design every single day. The whole industry grows at roughly 20% a year. This is the bet that a focused, fast-cycling factory can blow past that ceiling. And this tweet nails the contrast. TSMC makes thousands of different chips for hundreds of customers. TERAFAB makes 2. That's how you even begin to imagine terawatt-scale output, maximum repetition, minimum variation. The question is whether those 2 chips are actually enough to power everything in the stack. So what are the 2 chips? Line A is the Edge Army, cars running autonomy, inference on board, Optimus doing real-time perception and control, factories running local AI with low latency. None of these can wait for a round trip to a cloud server, they need to think on the spot. And here's what makes this demand curve scary. It scales directly with units shipped. Every car, every robot, every automated factory cell becomes a chip customer. Ship more units, need more chips, it compounds. This chart is where the whole thing either clicks or breaks your credibility meter. Cars, 2 million a year, robots at 10x that, 20 million. And the extreme case on the right, 200 million robots per year. If humanoids scale anything like that, the chip demand doesn't grow linearly, it goes near vertical. And that's the supply chain survival argument for TERAFAB. It's not ambition, it's arithmetic. If the robots ship, the chips have to exist. Now, here's where the vision meets the ground literally. Musk says the full TERAFAB can't even fit at Giga Texas. It needs thousands of acres and over 10 gigawatts of power at full scale. 10 gigawatts. For context, that's roughly the output of 10 nuclear power plants. This isn't a footnote, it's the kind of number that means years of permits, new transmission infrastructure, and serious political negotiation. And Sawyer Merritt ran the numbers on the footprint. Roughly 100 million square feet, 10 times the main Giga Texas building, which is already about a mile long. People hear fab and picture a big building. This is one of the largest industrial sites ever proposed. If that's anywhere close to accurate, we're talking about a construction project in a completely different category. And then there's Chip Line B, the D3, designed specifically for space. Look at what this slide says it has to do. Run hotter, survive radiation, keep operating when you can't reboot. It has to handle single event upsets, that's when a cosmic ray flips a bit in your processor, and total ionizing dose from years of radiation exposure. This is not a GPU you shove in a box and launch. Space compute is a completely different engineering discipline, and this chip has to stay alive when there's no service call coming. Musk called TERAFAB, quote, the final missing piece of the puzzle. And if you zoom out, that framing actually makes sense. Rockets, check. Robots, in progress. AI models, check. But if you don't control the chip supply, every one of those programs is dependent on someone else's factory queue. TERAFAB is the lever that closes the loop. So here's the full picture as this slide frames it. One megafactory Tesla, SpaceX, XAI joint venture targeting a terawatt of AI compute annually, feeding cars, robots, and space-based data centers. The upside, if it works, is compute abundance on a scale that reshapes the AI race entirely. The risk is just as large because, as NVIDIA's Jensen Huang put it, chip manufacturing is, quote, extremely hard, not just build the plant, but the engineering, the science, and the artistry. This is one of the hardest industrial games humans play, and they want to win it from scratch. SpaceX made it official with this post, next step towards becoming a galactic civilization and a public stream link. So it's out there now. The real tells going forward aren't going to be tweets, they're going to be land deals, power purchase agreements, equipment orders, and where the chips actually come out on the iteration cadence they're describing. If those dominoes start falling, this conversation gets a lot more serious, fast. Subscribe if you want to follow it because this one's going to move.